about 75 papers with more than 7,000 citations in Google's Scholar in the area of high performance computing, compilers, and virtual machine optimization, and has been granted 19 US patents. While at IBM, Manish received several awards for excellence. Dr. Manish is a fellow of ACM and the Indian National Academy of Engineering and a recipient of a Distinguished Alumnus Award from IIT Delhi. Please welcome Dr. Manish Gupta.
Thank you, Kamal. It's a pleasure to talk about our work. I hope my slides are visible.
Yes, those are.
Okay. Thank you. Okay, so I'll be really talking about our work, again, AI for India, which has been done by my colleagues. So while at Google Research, I mean, we are doing also a fair amount of fundamental research on the basic technology, in particular deep learning technologies behind AI, including kind of understanding and improving these technologies for issues like fairness, safety, explainability, and also understanding the human factors as these AI technologies interact with humans. I'll focus in this talk on some of the work that we are doing in applying AI in areas like healthcare. We also have a formal AI for social good program where we work with NGOs to work on problems that are motivated by, again, what they are doing for the communities. Some of our work with satellite imagery processing, which we are now applying to agriculture. And finally, trying to democratize access to information in Indian languages. So let me begin with our work in health, where I believe AI is really going to help transform the healthcare system pretty much globally. Because I would argue there's not a single country today which is happy with its healthcare system. I'm illustrating that with this slide, which is showing the per capita expense on healthcare in various countries. This is from the year 2018. The numbers for every country have now gone up from what these numbers, the numbers that are shown here. And you can already see, again, I mean, there are countries like the US where these expenses are out of control. In the US, you are spending over 10,000 US dollars, not when a person falls sick in a year, but this is on an average person. And countries like even UK, which have much lower amount of spend compared to the US, they're also struggling with rapidly rising costs. So trying to figure out how to really reduce these costs. And then when it comes to health, nobody wants to do it at the expense of quality, right? So you're also trying to improve the quality of the healthcare system. And the one country where these numbers are very low, below $1,000, is India. And somebody might think that India is doing a wonderful job with health. Whereas the reason this number is very small is because this is the average number. We don't have decent healthcare for much of our country. And therefore, that spend on healthcare when divided by our population of 1.3 billion becomes a small number. But as India goes about providing decent healthcare to every citizen, we simply cannot afford to take the path of countries like the US or even UK. We need to do much better. And what's that better path? I would argue it's a combination of a business model change and also something where technology can play a big difference. The business model change is to make healthcare more consumer-centric, where it is really trying to deliver value to the consumer for every rupee that is being spent on healthcare. The area where technology can make a difference is making it more proactive. We've all heard the term prevention is better than cure. And again, I mean, in COVID times, it became so much clearer, the emphasis on prevention of COVID, right? Through through simple techniques like masking, social distancing, if we can prevent COVID, right, that is so much better than having to treat COVID with all the medication and so on. And the same argument holds in general for almost every disease. So in fact, the healthcare system tends to be built in different tiers, and if through technology we can take care of a person's health at an earlier tier, it leads to lower cost and it also leads to better outcome for people. And that's illustrated, for instance, in the slide where the most expensive tier is the ICU of a typical hospital. So ICU is not a fun place to spend your night, and renting out this bed in an ICU is usually much more expensive than renting out a bed in an expensive 5-star hotel in an exotic location. So if you can take care of this patient before they enter the ICU, before they need to enter the ICU, when they are at the earlier stages in the hospital, it can both lower the cost as well as lead to better outcome for them. And taking that argument even further, if we can take care of people while they're living their normal lives at home, at work, and prevent them from falling sick, or when they do have symptoms or risks for specific diseases, if we can warn them ahead of time and encourage them to take timely action, that can lead to better outcome for people as well as lower costs. So, and it is in this early intervention, it is in early risk prediction where AI can play a very significant role. So what I'll do is I'll give 2 examples of the use of AI in this more proactive health, and show how many of these examples can generalize to multiple other diseases. So let's start with one example, which is on screening for diabetic retinopathy. So diabetic retinopathy is a fast-growing cause of blindness for people across the world, and it can potentially impact any person with a diabetes condition. So regular screening is really key to preventing blindness. And what happens is, in a country like India, which has a shortage of eye doctors, and in fact, this aspect is true not just for eye doctors. You take any specialty, India will have a shortage of that specialty relative to our population. So what ends up happening is, as a result of this shortage, for instance, for eye doctors, roughly half of the patients, 45%, end up suffering a vision loss before they are diagnosed with this condition of diabetic retinopathy. So, and the way it is diagnosed is through a special camera, the retinal fundus camera, that captures this image of the eye, the retinal region, and based on that image, usually the doctor basically looks for signs of hemorrhages in this image, and then they rate this case on a 5-point scale, where 1 indicates no diabetic retinopathy and 5 indicates proliferative diabetic retinopathy. So what our team, our AI team of researchers, starting with one of our researchers, Varun Gulshan, he did this work, in fact, before our research lab got established in India, when he had moved to India for personal reasons. And he started talking to various physicians, trying to identify an area in health where he could make a difference using his core capability, which was computer vision. So in computer vision, we've actually seen deep learning kind of really show that tremendous impact by showing that ability to analyze these images, right? And we have seen deep learning algorithms analyze pictures to be able to automatically classify these images. Is this an image of a cat or a dog? In this case, what we are trying to do is feed this deep learning network this image, this retinal fundus image, and train it to automatically classify whether on this image on this 5-point scale. So our team started with a whole bunch of these labeled examples, which were labeled by the doctors, and trained this neural network to automatically come up uh, uh, with these grades. And again, I mean, I'll skip some of the details. After a fair amount of work and a lot of improvements, they were able to show an algorithm that was able to achieve results comparable with a general ophthalmologist. And they published that work in 2016 in the Journal of American Medical Association. And this work got a fair amount of recognition and praise from the medical community. So in fact, you can see some of these quotes by a doctor from Harvard Medical School that the study by Gulshan and colleagues truly represents the brave new world in medicine. And in fact, last year, this paper was rated among the 10 best JAMA papers, this journal's papers in the last decade. And in fact, later, this team went on to improve these results further and showed results on par with retinal specialists. And not just that, they were able to start to show additional kinds of things that they could do with this analysis of these images, including predicting your risk for cardiovascular risk factors like heart attacks and strokes. And so this, I also want to kind of, sometimes we get carried away in the hype. So while on one hand, these results are extremely impressive, there are still some outstanding challenges that researchers are working on. And one of those challenges is that on the overall, on the average, algorithms like these deep learning networks are achieving results comparable with the specialists. However, there are still cases where these algorithms could make really terrible mistakes that no human doctor ever would. And unlike a human doctor, who normally, I mean, when they are presented with a complicated case, they know that this is a complicated case, and in that case, they might seek a second opinion. Deep learning algorithms can often make mistakes very confidently. So that's, again, so trying to estimate your uncertainty better is an active problem that many researchers are working on, including, our own team at Google Research India. And we have a collaboration with one of the professors, Professor Sridhar Devarajan at Indian Institute of Science on this problem. Now, to me, I mean, this example of screening for diabetic retinopathy, this is again representative of similar ways in which you can screen for other diseases. And in fact, researchers at Google have likewise shown deep learning based techniques through which you're able to detect, again, you can screen for breast cancers using, again, deep learning applied to mammography images. There are startups like Niramay, which are trying to do this by applying, again, machine learning over thermal images. There are researchers at Google who have also shown, again, similar success at applying deep learning for screening for lung cancer, various kinds of skin cancers, and so on. So again, this is a very promising area where applying these AI-based technologies, you can warn people early of potentially serious diseases. And when you warn them early, often the treatment is much simpler and much more effective. Another major disease that we are looking at at our lab in India is cardiovascular disease, which is actually the number one killer for people on the planet. And in fact, including India. In fact, in India, a number of people who die of heart attacks or strokes, there are two kind of, I mean, uh, issues I want to highlight. One issue is that most of the people who are suffering these heart attacks and strokes, unfortunately, are not even aware that they are at a high risk of these adverse events. On the positive side, which is the silver lining, I mean, you can view that as a negative. Uh, so in this work, we are collaborating with a cardiologist, Dr. Santosh Satish from JIPMER in Pondicherry. And Dr. Santosh tells us that in his analysis, a typical Indian is, is suffering a heart attack or a stroke at an age which is roughly 10 to 15 years lower than what, I mean, a counterpart in, let's say, a Western country would. So you can view that as a negative, that Indians are suffering these heart attacks and strokes at much younger ages. To me, the silver lining is that through early intervention, you can actually delay these heart attacks and strokes, potentially by, again, that at least a period of 10 to 15 years, and in many cases, help prevent them altogether through some very, very simple lifestyle interventions. And the goal of this particular research is to see if we can use, again, the combination of things like mobiles and wearables that we are all, I mean, that people are beginning to use. Can you extract out meaningful health signals from these wearables and mobiles, things like your blood pressure, your body mass index, heart rate variability, as well as your lifestyle factors like how much exercise you're getting, are you smoking or not, what kind of food you're eating, and so on. So in many cases, you have to take some of these signals you're getting out of these wearables and mobiles and further apply a combination of signal processing and AI to recover these health related signals. Then you build risk disease models based on AI again. And you can then, as you identify people with a high risk for a certain disease like cardiovascular disease, you can then also suggest simple interventions. So in case of something like, in case of cardiovascular disease, in fact, there are some very, very simple interventions which we are planning to now test through a clinical study that we are planning jointly with the doctors in JIPMER. The idea is to look at patients who do have hypertension and see if a combination of simple automated lifestyle suggestions about, look, you need to do more exercise, you need to start walking for about 15 minutes every day, or start increasing your intake of fruits and vegetables on your food. Please cut down your salt consumption to no more than 5 grams. These kinds of simple suggestions the idea is to show that through those simple suggestions, you should be able to bring down the blood pressure of a person with hypertension. And ultimately, a lot of these kinds of lifestyle suggestions, and if they don't work, if let's say the person still continues to have hypertension, then things like medication to keep your blood pressure and things like blood sugar levels under control, they can have, clinically it's well known that they can have a tremendous impact on improving your cardiovascular health. And so this work, again, in my view, can generalize to many other conditions as well, such as diabetes, uh, uh, as well as you can start to intervene early um, for other serious conditions like mental uh, depression, uh, 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 as well as mental illness. Uh, so, so one obvious concern that comes up when you look at some of these kind of technologies is that they are doing all of this analysis over data that tends to be very sensitive. Because what's my blood pressure? What am I eating? Am I smoking or not? How much sleep am I getting? Uh, these tend to be very sensitive uh, 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 kind of pieces of data which I may not want anybody else to know about me. Uh, so the so 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 another area which is really gaining a lot of attention from the research community is privacy aware machine learning and privacy preserving machine learning. So for a healthcare setting, one of the fundamental technologies that we are looking at building upon is called federated learning, which was initially developed at Google Research. And at this point, it is being used by many companies. And also, there's a lot of research happening in academia on improving these technologies further. The idea in federated learning is to help you uh, 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 to do this machine learning in a manner, in a very federated manner. And in this case, back to this healthcare example, you can do it by essentially guaranteeing, assuring the end user that their data is not to be stored, is not to be shared with any centralized system, including cloud. So in that original system, right, the way I was describing, you kind of bring all of the data from various individuals to a centralized cloud, and there you analyze it. In federated learning, rather than doing that, you will build some initial models with proxy data on a centralized server or cloud. You will distribute those models on individual devices, and then you will be running those machine learning models just locally on the mobile device of the person. And in this case, the sensitive data about this individual is not being sent anywhere beyond their device. It is not being shared with any centralized server. And the idea in federated learning is that you still want to be able to learn global models from each of these individual kind of data sources, right? When you have millions of users, each using their own mobile device, how can you train your machine learning models without getting access to the raw data? How can you still take advantage of the data on all of those millions of devices? And this is what you do in a federated manner, where you never share the raw data, but you start to share certain machine learning parameters like gradients that get used in the gradient descent algorithm um, uh, of your deep learning system, and you're able to update these models and ultimately distribute them. Uh, Now, somebody who's familiar with attacks, with privacy attacks on machine learning model would recognize that even if you're not sharing the raw data, uh, uh, somebody could still essentially attack the deep learning model and be able to recover back the data for an individual through those specific attacks. And again, to prevent those, one can combine something like federated learning with the differential privacy techniques, which essentially guarantee that the overall machine learning model that you learn, from that you're unable to recover the raw data, unable to identify any given individual. Uh, uh, I know I am kind of out of time, so very quickly I'll give you. I just wanted to go more into depth in one of the areas, which was health. Uh, in this, let me just give you a few more examples of where AI can be applied in other domains. So let me talk a little bit about agriculture, starting with some work that we have done. So our, again, computer vision team has been now looking at analyzing satellite imagery to see what kinds of interesting analysis you can do and what kinds of interesting problems you can solve by analyzing those satellite images. And they started by working with our Earth Engine team on this problem of land use, land cover classification, where the idea was for any point on the map, you want to automatically identify, is this a water body? Is this a forest? Is this an agricultural area? Is this a human settlement? And so on. And the idea is that once you do this classification automatically, it can help you with some very, very interesting and useful kinds of analysis, like what's happening to the forest cover in a given region, what's happening to water bodies in a given region. And so let me now talk specifically about some use cases in agriculture. You could also infer that, okay, this is a particular field. Now you could do further analysis of this satellite image and be able to infer what is the crop which is being grown. Is this wheat or rice? And what is the current stage that the crop is in? When is it likely to, ready for harvesting? So the idea is that by doing some of this analysis at the scale of by analyzing satellite imagery, you can do these analysis at a much larger scale in a much more cost-effective manner than if you were using traditional kind of techniques, either manual methods, which are often used today, where, let's say, for a bank which is trying to decide whether to give a loan to this farmer, or an insurance companies which has to provide crop insurance to this farmer, they want to see, okay, how much of that farmer's, let's say, plot is under cultivation for a given crop. Now, today, with manual analysis, you may need to send an agent to the actual field of that farmer, which is a very laborious and expensive process. The next step in that evolution is you can start to have kind of drones or photographs that are taken, let's say, of the field. You can have ground-based sensors, IoT sensors, through which you are sensing things like soil moisture and so on, and start to help farmers with these analysis. What we are trying to do is work again with such technologies, with various ground-based sensors, to provide the ground truth and see if we can build effective models by analyzing satellite imagery. So starting with things like soil moisture readings that you have of a field, can you actually infer the soil moisture level simply by analyzing satellite imagery over that particular field? Because if you are able to do that, it helps you do all of that analysis at very, very large scales and in a much more cost-effective manner. And in turn, you can pass on those benefits to the insurance companies and banks, which in turn can then pass on those efficiency benefits to the farmers and provide them, again, that loan at a lower rate or that crop insurance at a much more reasonable level. Because today, I was shocked to learn that crop insurance for farmers is often outrageously priced, where they might need to pay something like 25 to 30% of the price of the crop for getting that crop insurance because of all of those inefficiencies. The final uh, quick topic that I'll cover very quickly is democratizing access to information. I know, uh, uh, many of us, the first thing that we do when we are trying to access any information is we start with something like a Google search. Uh, and what we are trying to do is to cater to all of those hundreds of millions of our fellow citizens who, unlike those of us who are kind of in this conference, so somebody like, let's say, a laborer's son in Chhattisgarh or a farmer's daughter in Assam, how do we empower them with the same kind of access to information as all of us, right, who are attending this conference? Uh, so a major difference is that for people like us who understand English, uh, we have access to much richer information on the web. Uh, but for somebody who doesn't speak English, often the amount of information that is available to them is much lower, and often the quality is much poorer. So I'll skip some of these details, just kind of very briefly mention that there are some very interesting challenges, because I mean often, for instance, one thing that we do in India is we do this code mixing. We mix up multiple languages. This is an example of Hindi and English being mixed in the same query, uh, in the same sentence, which means that you cannot just have an English-based model or a Hindi-based model trying to process this query. You need a multilingual model to be able to process this. And at Google, we did have this multilingual technology, the multilingual version of BERT, which we realized wasn't doing very well on Indian languages. So our team here has developed this Indian counterpart, which is Mural, multilingual representations for Indian languages, which has been trained on, again, a corpus with 16 Indian languages and English, and is achieving significantly improved accuracies. We also have kind of related efforts that we call Indophoneme, because we often see on things like Google search or the Google voice assistant misspelling or mispronunciations, which are often influenced by our native language. And what we are trying to do is to make these query processing engines robust to all of these different variants. Because when you think about them deeply, while the spelling looks a bit odd, but when you look at it, think of it phonetically, it does make sense, right? To think of writing furniture in this manner. So how do we make our speech recognition and query processing systems robust to all of these variants? This is something which has been done by this Indophoneme team. And again, as more and more AI begins to impact the real world, it also becomes very important to look at, again, these basic principles, given issues like potentially biases that AI technologies can perpetuate. So at Google, we have also established a set of AI principles where we have started basically analyzing all of our research efforts and our products to see are they abiding by these principles. And also we have, again, identified a set of AI applications that we will not pursue that are likely to cause overall harm. And the idea is to be able to then take all of these advances in AI to be able to solve real world problems and make a positive difference to the world at large. So hope I've given you a flavor of what's possible. But again, in my view, that's just the tip of the iceberg. And there's a lot more that the external world can do and is already doing. And over the coming years, we look forward to both collaborations and enabling through frameworks like TensorFlow that we have been contributing to and so on, enabling uh, 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 basically a whole bunch of people, both inside and outside Google, to be able to solve many of these problems arising in areas like health, agriculture, transportation, education, and make a difference to the world. So let me stop here. Apologize, I think I've gone over a bit, and if there is time, I'm happy to take a few questions. Thank you.
Thank you, Dr. Manish. Very insightful, presentation, and I think there were few questions. But looking at your presentation, I think most of those were answered by you. And I'll just read one question, which probably you have already answered. Looks like AI is benefiting rich more than poor currently. Do you agree with it? Would you like to make the last comment on that? Looks like we lost the audio here.
Network. I think you were saying technology benefiting the rich more than the poor.
AI is benefiting rich more than poor. Do you agree with it?
So I would both agree as well as disagree. I mean, I would agree that today the benefits of AI have gone much more to the rich. Is there potential to benefit the poor as much as the rich? I would say absolutely. And a lot of the emphasis of our AI for social good effort is primarily, again, these marginalized communities which have not seen the benefits of technologies like AI, and which is why we have been working with all of these NGOs, and I had to skip over some of that work. And in fact, we launched 6 projects last year, and we realized, I mean, while we made good progress on many of these projects, we realized there's so much more to be done. So this year we are expanding the scope to about planning to launch 30 new projects with NGOs supporting different communities. Again, our goal is to eventually impact over 1 billion people from the disadvantaged communities that are not yet touched by AI. But yeah, today I would absolutely admit that technologies like AI have benefited the rich far more, but there is clearly potential to, in fact, help bridge that digital divide using technologies.
Thank you so much, Dr. Manish. The future looks brighter, and we want to wish you the best.
Thank you.
Thank you for the participation in this summit.
Thank you.
So with that, we would